Welcome back. So, today we will be seeing another type of say test by which you can find out the shear strength of soil, that is nothing but unconfined compression test on saturated clay, right. So, the unconfined compression test is a special type of unconsolidated undrained test that is commonly used for clay specimens. So, this test, that is this unconfined compression test, is basically used for your clay specimen, and this is a special type of UU test whatever you have seen earlier, right. So, unconsolidated undrained means you are not considering drainage at any point of time during the test, right. So, it is pretty similar to that, only difference is that in this test sigma 3 is 0. Now, if sigma 3 is 0, then what you can think of? So, if sigma 3 is 0, that means your confining pressure, that is the sail pressure, is not there. So, that means you are considering a cylindrical soil sample and you are shearing it with the application of only axial stress, that is your sigma 1, right. So, there is no sail pressure or all round sail pressure acting on the soil sample. So, because the undrained shear strength is independent of the confining pressure, as long as the soil is fully saturated and fully undrained, we have. So, basically before that, I mean already we have discussed this thing in detail, that in case of undrained shear strength, if you are considering, I mean if you are talking about a UU test and if you are trying to find out the undrained shear strength, basically it is independent of the confining pressure, right. So, I mean no matter whatever confining pressure you use, I mean you will be getting the failure line which will be touching the Mohr circle, and this confining pressure, I mean whatever confining pressure you will be applying, based on that basically you will be getting the David's stress. So, the confining pressure really does not matter in case of undrained shear strength determination, right. So, therefore, as long as soil is fully saturated, that means you are not considering the partially saturated soil, that means there is no air void or there is no air particle, or I mean the void space is completely filled with water. So, there is no air inside the soil specimen. In that situation, and if you consider fully undrained condition, that there is no drainage happening in the soil sample during shearing, therefore, the tau f, that is the failure shear stress, that means that is nothing but your shear strength is nothing but sigma 1 by 2, right. So, basically what is happening, you are not considering sigma 3, that is all round confining pressure is not there, you are just applying sigma 1 in the axial direction and you are shearing it till the failure. So, you will be getting the Mohr circle, okay, with sigma 3 is 0 and there is some value of sigma 1, and that will cause the failure, and therefore, the tau f, that is the failure shear stress, that is the shear strength, is nothing but sigma 1 by 2, that is nothing but the radius of the Mohr circle. Am I right? That is the radius of the Mohr circle, which is nothing but Qu by 2. So, and is nothing but Cu, that is undrained cohesion. So, where Qu is nothing but the unconfined compression strength. So, the Qu is defined as the unconfined compression strength in the soil mechanics. So, basically if you look at this figure, so it will be clear to you, basically in case of unconfined compression test, you have the situation like that, you do not have any sigma 3, only sigma 1 is acting axial direction, and therefore, so this state of stress, if you want to plot in shear stress versus normal stress space with the help of Mohr circle, then this will be your sigma 3, that is 0, and this will be your sigma 1, that is nothing but Qu, that is your unconfined compression strength, okay, and this point is the center, and this is basically your Qu by 2, and that is nothing but tau f, right. So, already we have seen that thing, okay, in the previous equation. So, this is your shear strength, right. So, in this situation you will not be getting any phi angle. So, everything, I mean the failure envelope will be horizontal and will be parallel to the normal stress axis, therefore, all the times you will be getting the cohesion. So, in case of soil, so clayey soil, you will be getting this kind of behavior from the unconfined compression test setup, okay. So, theoretically for similar saturated clay specimens, the unconfined compression tests and the unconsolidated undrained triaxial test should yield the same values of Cu. Do you agree with this or not? Because for similar saturated clay specimen, already we know that if we talk about EU test is not dependent on the confining pressure. Now, if it is not dependent on the confining pressure, then it is it is no matter whatever confining pressure you are considering, you will be getting the same strength, right. So, that means in that situation you can consider the confining pressure is 0 also, because it is independent of the confining pressure. So, you can also consider confining pressure is 0. So, that is why it is told that the similar saturated clay specimens, the unconfined compression test and the unconsolidated, that is EU triaxial test, should yield the same values of Cu theoretically. Okay. But practically, in practice, however, unconfined compression tests on saturated clays yield slightly lower values of Cu than those obtained from EU test. Okay. But theoretically they should be same, because the undrained strength is not dependent on the confining pressure. So, therefore, you will be getting same amount of shear strength from both the test, EU test as well as unconfined compression test. However, in practice, your unconfined compression test result, that is the value, that Cu value obtained from unconfined compression test, that is UC test, is slightly lower than the Cu obtained from the EU test. This is generally seen in the practical situation. However, in theory they should be same. Now, coming to the concept of stress path, this is another very fundamental concept and you must understand this concept. And once you understand this concept, though this is beyond the scope of our study in this particular course, however, the stress path will be very useful as well as helpful when you will be talking about the critical state soil mechanics. So, that means camp clay model and other things, there at that time stress path will be playing a major role or the important role to understand the concept. Okay. However, so that is beyond the scope. So, I will not talk about that type of say critical state soil mechanics or the failure envelope and all those things. However, we should know what is stress path, how we can establish the stress path and what significant information I will be getting from the stress path. So, a stress path is a line that connects a series of points, each of which represents a successive stress state experienced by a soil specimen during the progress of the test. Okay. So, it says that stress path is a line, it could be linear, it could be non-linear, that means curved line, okay, that connects a series of points. So, you will be getting a series of points and through which you will be getting, if you join those points, basically you will be getting the line, and that line will be indicated as the stress path. Now, what are those points? So, each of which represents, so each of these points will represent a successive stress state. That means, suppose you are doing some consolidated drain test, or if you are doing some consolidated undrained test, whatever test you are performing. So, basically what you are doing, first initially you are applying the confining pressure and then you are shearing it through the deviatory stress. Now, at each and every point you are getting different state of stress, right, different combinations of your sigma, sigma 3 is constant. So, different combinations of your sigma 3 and sigma 1, that combination is getting different, that point is not a fixed point, it is a variable points, right, during the progress of the test. So, during that time, so each point, if you see, each point will tell you about how the stress has progressed, how the test has progressed, right. So, if you see the stress path, then you will be seeing, okay, the test, that whatever test you are talking about, that test has progressed along this path. That means, each point on the stress path line or the stress path will be indicating the state of stress at different situation or different state of say test. Okay. Lamb in 1964 suggested a type of stress path representation that plots Q prime versus P prime, that is popularly known as QP plot, okay, where P prime and Q prime are the coordinates of the top of the Mohr circle. Now, what do you mean by top of the Mohr circle? So, if you try to draw the Mohr circle, this is your say tau versus sigma plot, and if you plot a Mohr circle. Okay. So, it says that you are plotting the stress path in q prime p prime space, where p prime and q prime are the coordinates of the top of the Mohr circle. So, top of the Mohr circle is here, right. So, top of the Mohr circle is lying here. So, this is the coordinate. So, this is your sigma and this is your say tau for this point. So, these two things we will be talking about p and q. So, they are expressed like that. So, p prime is expressed as sigma 1 prime plus sigma 3 prime, everything is expressed in terms of effective stress. So, sigma 1 prime plus sigma 3 prime by 2. Okay. So, that means if you recall, so this is your Mohr circle, this is your tau, this is your sigma. So, this is the center of the Mohr circle and this is the peak point, okay, of the Mohr circle. So, p prime, this is nothing but your p prime, right, from here to here, right. Sigma 1, this is your sigma 1 prime, say if I plot in terms of effective stress, this is your sigma 3 prime. So, sigma 1 prime plus sigma 3 prime by 2 is nothing but the distance of the center from the origin, agreed. Okay. Similarly, q prime, what is q prime? Q prime is sigma 1 prime minus sigma 3 prime by 2. What is that? That is nothing but the radius. So, this is your q prime. Okay. So, this is your q prime. So, sigma 1 prime minus sigma 3 prime by 2, that is nothing but the radius of the Mohr circle. So, that is why this p prime and q prime, this will indicate the highest point of the Mohr circle. Okay. So, highest point is lying here only. Now, let us consider a normally consolidated clay specimen subjected to an isotropically consolidated drain test. What we are considering? I mean, we are considering some kind of test, and let us see how we can develop the stress path for that particular test. So, we are considering a normally consolidated clay specimen subjected to an isotropically consolidated drain test. Okay. So, you are considering normally consolidated clay. So, there will be only phi. So, C will not be there, as already we have seen, okay, for the consolidated drain test, that there is no C intercept, because C intercept you will be getting for the over consolidated clay. So, you are talking about the normally consolidated clay. So, you will be getting only one line which is inclined at an angle phi, that is the angle of internal friction with the sigma axis, right. And this is isotropically consolidated drain test we are considering. So, at the beginning of the application of deviatory stress, right, at the beginning of the application of the, that means there are two stages, right. I hope that you still recall, there are two stages of the triaxial test. One is that you are applying the confining pressure, you are consolidating that thing. In case of CD test, we are doing that, right. In case of CD test, first you are consolidating some sample with the help of your confining pressure or the cell pressure, and then after that you are shearing it with the help of deviatory stress. So, before application of the deviatory stress at the beginning, so sigma 1 prime is equal to sigma 3 prime is equal to sigma 3, agreed, because you are applying all round cell pressure. So, sigma, so radial direction, whatever stress is there, the top direction also the stress will be same, the axial direction. So, the sigma 1 will be nothing but equal to sigma 3 will be nothing but equal to total stress, that is sigma 3, say. Okay. So, in this situation I can calculate p prime by the equation given just now. Okay. So, sigma 3 prime plus sigma 3 prime by 2, which is nothing but sigma 3 prime, and it is eventually equal to sigma 3, right. The effective stress and total stress must be same under CD test. Okay. Now, what will be the value of q prime? That is simply 0, right, because you are getting sigma 1 is equal to sigma 3. So, q prime is 0. So, now if you see this, so for condition 5.28, so what you have got? See, p prime is sigma 3 and q prime is 0. Now, in this space q prime versus p prime space we are plotting. Okay. So, the for condition 5.28 and 5.29, p prime and q prime will plot as a point, that is I. So, that is the point. So, this is the point which will be indicated by 5.28 and 5.29 already we have seen, where we are getting sigma p prime is equal to sigma 3 and q prime is equal to 0, right. So, this is the point. So, I point will indicate that is nothing but the initiation of the test. So, that means you are just starting the test before applying the Debye-Trix test. This is the condition, this is the situation. So, this point, whenever I am seeing this point, so basically I will be understanding this is isotropically consolidated sample. Okay. So, shear is not happened till now. Okay. Now, at some other time during the Debye-Trix test application. So, now you are applying the Debye-Trix test at any other time. So, sigma 1 prime will be equal to sigma 3 prime plus delta sigma d, agreed. So, sigma 3 prime will be your cell pressure, that is already there, and that will be always there during the test, plus the Debye-Trix test sigma delta sigma d. So, sigma 3 prime plus delta sigma d is equal to sigma 1 prime, which is nothing but, because you are considering drain test. So, that is nothing but equal to the total stress, that is sigma 3 plus delta sigma d. Okay. Now, what about sigma 3 prime? Sigma 3 prime is already equal to sigma 3 and that will be remaining constant throughout the test. So, sigma 1 prime I have got sigma 3 plus delta sigma d and sigma 3 prime is equal to sigma 3. Now, the Mohr circle marked A corresponds to this state of stress. So, now if you see this figure, basically the Mohr circle A, this is the Mohr circle A. So, that will indicate, so this Mohr circle will indicate that this is your sigma 1 prime and this is your sigma 3 prime. So, this Mohr circle will indicate that state of stress, am I right. So, you started the test only through a point, okay, and then you are increasing the Debye-Trix test, therefore, your sigma 1 is getting increased and that is why you are getting the failure. Now, you are going up to the failure, say, or at any stage, not up to the failure, say at any stage your sigma 1 prime will be obtained by this expression. So, that is nothing but sigma 3 plus delta sigma d, which will be giving you the sigma 1 prime and sigma 3 of course, that will be there. So, this circle Mohr circle A will represent that state of stress, agreed. Okay. The values of P prime and Q prime for this stress condition for say Mohr circle A. Now, we are going to find out P prime and Q prime when the state of stress is represented by the Mohr circle A. So, at that time P prime is equal to, that will be remaining same, that expression is constant, that is the distance of the Mohr circle center to the from the origin, right. So, sigma 1 prime plus sigma 3 prime by 2, which is nothing but, so sigma 1 prime is this plus sigma 3 prime. So, ultimately you will be getting sigma 3 prime plus delta sigma d by 2 and because you are considering drain test, it is equal to the total stress. So, sigma 3 plus delta sigma d by 2. Okay. Now, in case of this condition, what is the magnitude of Q prime? So, Q prime is sigma 3 prime plus delta sigma d, that is nothing but sigma 1 prime, this is your sigma 1 prime, right. So, this is also your sigma 1 prime. So, this your sigma 1 prime minus sigma 3 prime by 2, which will be nothing but delta sigma d by 2, right. So, these conditions 5.30 and 5.31, these conditions represent a point d prime at the top of the Mohr circle, right. So, this is the point, agreed. So, this is the point, that is nothing but the topmost point of the Mohr circle A, which will be representing the P prime and Q prime at that state of stress, agreed. Okay. Now, so if the values of P prime and Q prime at various stages of the Debye-Trix stress application are plotted and these points are joined, then a straight line like ID will result. Okay. So, now we are continuously monitoring the test and we are continuously monitoring the sigma 1 prime. So, Debye-Trix stress basically. So, sigma 1 prime will be always equal to sigma 3 prime plus delta sigma d. So, at some point, at some stage you have got Mohr circle A, then at the next stage when you are increasing the Debye-Trix stress, you have got this circle and another circle, say something like that, and so on, and ultimately you have got this Mohr circle, when this Mohr circle will be talking about the failure, that Mohr circle B will be talking about the failure, because it is touching with the failure envelope OF, agreed. So, this is touching at this point. So, till for circle A there is no failure, this is the progress of the test. As the test is progressing, you are getting different Mohr circles, right. So, when you reach the Mohr circle B, at that time you are getting the failure, and at that time you are denoting that point. Okay. So, because these are the points you are getting, I told you that you will be getting several points and then you will be joining these points to get the stress path. So, this ID is a kind of straight line, agreed. So, this will be your straight line, okay, and this straight line will be known as the stress path, which will be defining the state of stress for the isotropically consolidated drain test. Okay, understood how the stress path is getting developed. Okay. Now, the straight line ID is referred as the stress path in a Q prime P prime plot for a consolidated drained triaxial test, as I told you. So, now you have got this is your stress path. So, if I get this kind of stress path, I will be knowing how the test has progressed. That means, all these points on the stress path will be denoting the state of stress, okay, at every stage of the test, okay. And ultimately when you will reach point D, so that Mohr cycle, corresponding Mohr cycle, will be talking about the failure. Now, ID makes an angle of 45 degree with the horizontal, because this angle is 45 degree, agreed, because this is also radius, this is also radius, this is also radius, this is also radius. So, this angle is 45 degree, okay. So, ID is a straight line and it will make an angle 45 degree with the horizontal. Now, point D represents the failure condition of the soil specimen in the test, agreed, because when you reach at point D, after that you cannot extend the stress path like that, because you cannot have the access, because soil has already failed. So, when you reach at point D, at that time the specimen will tell I have failed in the test, right. So, also we can see that Mohr circle B, okay, represents the failure stress condition, because it is touching the failure envelope at this point. So, Mohr circle B is touching the failure envelope OF, and therefore, it will give you the failure, and the corresponding point on the stress path is nothing but point D, that is the topmost point of the Mohr cycle. For normally consolidated clay, the failure envelope can be given by tau f is equal to sigma prime into tan phi prime, that is line OF, agreed. So, that is not new, that already we have seen when we talked about the CD test, okay. So, tau f, that is the failure envelope, is equal to sigma prime tan phi prime, and that is denoted by the line OF. So, a modified failure envelope can be obtained by line OF prime, okay. So, now you see this dotted line. So, this dotted line, okay, this OF prime is giving you the modified failure envelope. How you are getting OF prime? So, you have got the failure Mohr circle, that is B. Once you got the failure Mohr circle B, and you can establish the point D, because that will be the topmost point of the Mohr circle at failure, and that will be also lying on the stress path. So, once you know the point D, you join that point D with the origin, and you will be getting one line OF prime, and that is nothing but your modified failure envelope, okay. So, when you are joining the stress path, okay. So, stress path, the points on the stress path will be talking about the the points whichever will be lying on the stress path, that points, all the points will be talking about the stages of stress application on the specimen, and ultimately when you are getting the failure, if you join that point with the origin, you will be getting the modified failure envelope. So, this modified line is commonly called as KF line in soil mechanics. So, maybe in some book, in some literature, in some journal papers or research papers, you will be if you see the KF line, if they are mentioning about the KF line. So, KF line is denoted by this modified failure envelope, that is OF prime. So, OF prime is nothing but your KF line. Now, the equation of KF line is nothing but Q prime is equal to P prime tan alpha, where alpha is the angle of inclination of OF prime with the horizontal, okay. So, Q prime is equal to P prime tan alpha. Now, we are going to establish the relation between alpha and phi prime. So, is there any relation or not, that we are looking for first, and then we will be trying to establish the relation between alpha and phi prime. What is alpha? That is the angle of inclination of the modified failure envelope, and what is phi prime? That is the angle of inclination of the original failure envelope, right. So, in this figure DO prime by OO prime is equal to tan alpha. Okay. So, therefore, tan alpha is equal to, what is the coordinate of DO prime and OO prime? DO prime is nothing but the radius of the Mohr circle. So, that is given by this sigma 1 prime minus sigma 3 prime by 2, and what is OO prime? That is nothing but the distance of the Mohr circle center from the origin. So, that is nothing but sigma 1 prime plus sigma 3 prime by 2, and we are getting sigma 1 prime minus sigma 3 prime by sigma 1 prime plus sigma 3 prime, right. Similarly, I can get CO prime by OO prime. So, CO prime is this, okay. So, C is nothing but the point where the Mohr circle is touching the original failure envelope, okay. CO prime by OO prime, that is nothing but sin phi prime, okay, because this angle is phi prime, okay. So, sin phi prime is again is equal to sigma 1 prime minus sigma 3 prime by sigma 1 prime plus sigma 3 prime, okay. So, from equations 5.33 and 5.34 we can write, because both right hand side is same. So, sin phi prime is equal to tan alpha. So, therefore, we can write phi prime is equal to sin inverse tan alpha. So, this is the relation between phi prime and alpha. So, phi prime is equal to sin inverse tan alpha, right. So, that means if you know the inclination or the angle of internal friction of the original failure envelope or the original soil sample, then basically if you want to find out the modified failure envelope, then you can find out alpha from this expression, right. And once you know phi, that means you can find out alpha, and therefore, you can find out the location or the orientation of KF line, okay. Now, let us consider a normally consolidated clay subjected to isotropically CU triaxial test, okay. What we are considering? We are considering now the normally consolidated clay, again normally consolidated, we are not talking about the over consolidated, we are talking about the normally consolidated clay subjected to isotropically CU, that is consolidated undrained triaxial test, okay. So, I will stop here today. In the next class, we will take this example and we will try to develop the stress path for this isotropically CU triaxial test. Thank you very much.